The center of the Milky Way is a story of intense radiation, gravity, and mystery. A place where the forces of nature are pushed to their limits. But what if our own planet were to find itself in this cosmic theater? What would happen if the Earth were located there and somehow managed to survive? Let's start this journey to the heart of our galaxy and find out. Picture this. You're floating in space, surrounded by billions and billions of stars. Suddenly, you see a bright swirling mass of gas and dust in the distance. That, my friend, is the Milky Way galaxy, our home in the vast expanse of the universe. The Milky Way is estimated to contain over 100 billion stars and is about 100,000 light-years across. In other words, if you were traveling at the speed of light, it would take you 100,000 years to cross the Milky Way from one end to the other. It's a couple trillions of miles. And it isn't just a static collection of stars and gas. It's a dynamic, evolving system. In fact, the Milky Way is currently hurtling through space at a speed of about 1.3 million miles per hour. One of the most fascinating things about our galaxy is its shape. The Milky Way is a spiral galaxy, which means that it kinda looks like a disk with a central bulge and spiral arms. The spiral arms are the areas where new stars are born. It's where the most stars, gas, and dust are concentrated. And this is where the solar system is located. Our system is like a tiny speck in the grand cosmic tapestry of the Milky Way. It's about 26,000 light-years away from the center of the galaxy. A pretty long distance, isn't it? The solar system is also moving through the Milky Way as it orbits around the galactic center. It takes about 230 million years for our system to make one complete orbit around the galaxy. Just imagine that. Since the time of the dinosaurs, we've traveled just a quarter of this way. The position of the solar system in the galaxy affects our life in many ways. For example, things like the amount of radiation and cosmic rays we're exposed to, and even the likelihood of asteroid impacts, and so on. Also, thanks to our location, we can enjoy some pretty amazing views of the universe around us. From our vantage point in the Milky Way, we're able to see other galaxies, nebulae, and star clusters in breathtaking detail. We're also a part of a pretty happening neighborhood, with lots of other stars and planets nearby, so we're lucky fellas. But what would happen if we weren't so lucky? What if the Earth was located in the center of the Milky Way instead? The center of the Milky Way is home to a region of space called the central bulge, and it's just packed with stars. It's like a disco ball, but instead of shiny mirrors, it's covered in stars. Only this disco ball is really huge, about 10,000 light-years in diameter. The center of the Milky Way is also home to some extreme environments that would make even the bravest astronauts shiver. High-energy particles and intense magnetic fields can wreak havoc on electronics and spacecraft. Intense radiation fields can fry anything in their path, so it's not exactly a friendly place for life as we know it. So, if the Earth were located somewhere closer to the center of the Milky Way galaxy, it would be a very different place. Let's take a look at some of the potential effects. First of all, radiation. As we mentioned earlier, the center of the Milky Way is one of the most radiation-dense regions in the galaxy. It would make life on Earth very challenging, if not impossible. Sure, we have the Earth's magnetic field. It's like a giant shield that protects us from harmful radiation from outer space. But could it protect us if we were located in the center of the Milky Way? Unfortunately, the answer is no. It's kind of like trying to use a tiny umbrella to protect yourself from a massive storm. So it would be an easy win for the galaxy. But it's not all doom and gloom. There are some brave organisms that are able to adapt to high levels of radiation. We've seen that life on Earth has evolved to survive anywhere, from the depths of the ocean to the icy poles of the planet. So, Let's imagine what would happen if we somehow evolved to survive in these harsh conditions. Like, picture humans with tough, scaly skin that protects them from radiation, and plants with unique structures that allow them to thrive in this bright environment. In that case, radiation could still have some seriously spooky effects on us. For example, it could damage DNA molecules and cause mutations. Imagine a world where plants grow with 5 leaves instead of 4, animals have strangely colored fur, or people have unusual eye colors or other unique features. And these are just some of the best examples. Let's not dive into the bad ones. Also, it could cause us to undergo some metabolic changes. Maybe our bodies could process food and other resources more quickly, which could lead to faster growth rates and larger sizes. Plants could grow tall and thick, and animals would be much larger than usual. There are also some organisms on Earth that are able to bioluminesce. Thanks to high levels of radiation, these organisms could potentially glow even brighter than usual. Imagine walking through a forest at night and seeing trees, mushrooms, and even insects glowing with an eerie blue or green light. Frightening and amazing, isn't it? But let's move on to the next big change: gravity. The gravity in the center of the Milky Way is incredibly strong, all thanks to a supermassive black hole, which is about 4 million times the mass of the Sun. This black hole is called Sagittarius A. And yep, it's our neighbor now. Great. And assuming we don't get swallowed by this black hole or crushed by this incredibly strong gravity, it still could trigger lots of earthquakes and volcanic eruptions. This black hole would be like the gravitational bully, pulling and tugging at everything in its path. Basically, if we survived this, we'd have an epic surfing competition every single day. Just add a bit of the thrill of risking your life, and forget about running away from the planet. No easy rocket launches anymore. And physical objects won't be the only ones affected by gravity. Time would flow very differently for us. According to Einstein's theory of relativity, time passes more slowly in areas of high gravity. In other words, Earthlings would age more slowly than someone far from the center of our galaxy. Also, the center of the Milky Way is a very busy place. Stars, planets, and other celestial objects moving around at incredibly high speeds there every day. The positions of stars and other objects would be constantly changing. In other words, say goodbye to normal navigation. The GPS system would likely be unreliable due to the strong gravitational forces and high radiation. So, if you accidentally got lost in a glow-in-the-dark forest with some creepy animals, good luck. But it's not all bad. The center is also home to molecular clouds. These are the regions of space where new stars are born. And the Milky Way in general has some pretty amazing sights to offer. For example, stunning nebulae like the Orion Nebula and the Eagle Nebula, which are visible with telescopes or even just a good pair of binoculars. So, if Earth were located in the center of the Milky Way, we would have a front row seat to some of the most spectacular cosmic events. Wouldn't that be awesome? Overall, if Earth were located in the center of the Milky Way, it would be a very different place. Of course, we all understand that our planet wouldn't have survived such a change. But it's still pretty interesting to imagine how our life would flow if we were there. And judging by what we just discussed, it wouldn't be pretty. So let's treasure and appreciate our small, quiet solar system.
It's a clear night, and you're outside looking at the stars. The Milky Way alone seems overwhelmingly huge. You check on your phone and discover that the galaxy you're in at this exact moment is 100,000 light-years wide. For scale, 1 light-year is already a very long distance. For example, it takes 4.2 light-years to go from Earth to Proxima Centauri, which is the closest star to our planet other than the Sun. So, 100,000 light-years is way more than we normal humans can fathom. And that's just one galaxy. There's a whole lot more out there. Now, looking at this data, it seems pretty unlikely that we're the only life form out there, doesn't it? But how come we've never found anything else so far? Let's get one thing out of the way. Extraterrestrial life doesn't necessarily mean we're talking about little green people. It can also mean microorganisms, bacteria, and plants that can be found on other planets. The truth is, there's a big spectrum of possibilities for life on another planet. And taking into consideration that there are up to 50 billion planets in the Milky Way, it's very unlikely that we're alone in this big wide universe. And what does life on other planets look like? This is what we've spent years trying to figure out. Go ahead, think with me. A planet may be lifeless today, but it could have traces of organic matter or fossils, meaning that some life form was able to thrive there once. And it could also be that there are planets out there containing life with complex biochemistry, meaning they could have fauna just like we have on Earth, although probably not the same. NASA created a special science that is dedicated to studying life forms outside of Earth. It's called astrobiology. Ever since the space agency was created back in 1958, it didn't take long for it to start looking for extraterrestrial life. They quickly built an action plan. First, they needed to understand how life on Earth was formed, and secondly, how it could have formed on other planets. The first time NASA tried to look for life in outer space was in 1976. The Viking lander blasted into space, headed towards Mars. There were high expectations that humanity would find the first proof of extraterrestrial life. Unfortunately, the lander came back with images of a planet that looked barren and bleak, and scientists were extremely disappointed. Scientific conclusions on whether life could be detected over there were confusing. But hey, you need to know what you're looking for to find it, right? The failure of the Viking mission served to heat up debates amongst NASA scientists to define what life actually meant. And it also served to call their attention to a small but very important detail. Spacecrafts departing from Earth usually transport Earthling microorganisms and bacteria unintentionally, as they remain attached to the vehicle. It turned out that these bacteria could contaminate scientists' samples, so they needed to consider this. All of this made Mars expeditions take a back burner on NASA's short-term plans. There appeared a new priority-first question. What are the types and stages of life that space programs can hope to identify? Scientists might have encountered life on other planets, but they weren't able to identify it as life. That is why NASA began to study our own planet better. They studied everything, from ancient life forms that lived billions of years ago to living creatures that roam the planet today. They understood that the search needed to happen inwards as well as outwards. Let's take a look at the development of Earth's life from its inception. Imagine that this development can be represented as a ladder, or stairs, and each developmental stage is a flight of the bigger staircase. First, we would see basic chemistry, a soup of loose chemical elements like the ones we see in the periodic table. But they need to assemble themselves into more complex structures to be able to self-replicate, change, and evolve. This would happen in the second step, where we start to see the formation of microscopic organisms. In the third step, these cells combine to become multicellular beings, allowing for more complexity and variety. The step above sees species that can evolve big brains, enabling the use of tools, culture, and shared knowledge. That's where humanity is located. Looking at this ladder, one might ask, so what does it take for a multicellular organism to evolve into fully formed humans? This is what is called the Great Filter. It's a huge evolutionary jump that takes a lot of effort and the perfect environmental conditions for it to happen. And given that we haven't heard of any other extraterrestrial civilizations out there, it might be that we're the only ones that were able to make this jump. After all, how likely is it that we'll find life outside of Earth that is similar to us? That depends on how many planets there are out there in their star's Goldilocks zone, the area around a star where water can be liquid. And because stars come in all sizes and configurations, this zone is different for every star system. But that's not the only criteria we know for the existence of life. We usually look for three things to detect life: liquid water, methane, and oxygen. Water is what allows for chemical components to mingle and connect, forming multicellular beings. Methane is produced by the decomposition process made by bacteria, and oxygen is the byproduct of plant respiration. These are some of the telltale signs that the James Webb Telescope was programmed to search for. The James Webb Telescope has ambitious purposes that might revolutionize space science. Its top priorities are to detect forms of life by studying small galaxies orbiting the Milky Way. It will also look for the oldest stars in the universe, trying to gather data on the origin of the universe itself. That's huge! NASA is betting on two variables with this new telescope: a thorough scan on the so-called exoplanets, aka planets from outside our solar system, and the search for extremophiles, a type of life that loves extreme environments. Extremophiles were first discovered on planet Earth back in the 1960s at the bottom of the sea near the Galapagos Islands. Scientists found microorganisms living next to hydrothermal vents that dot the sea floor over that part of the world. Thriving in places like these with extreme temperatures over 700 degrees Fahrenheit takes a lot of resistance. I mean, can you imagine the heat? This discovery was a turning point for the field of astrobiology, as scientists understood that life could survive in extremely harsh conditions, similar to the atmosphere available in several exoplanets. But hey, life might turn up in our own neighborhood if we're lucky enough. Guided by the mantra, "Follow the water," NASA is launching two important missions inside our solar system that can contribute largely to the search for extraterrestrial life. You remember Jupiter, right? It's the gas giant that has a moon known as Europa. A few years ago, scientists discovered that Europa had an ocean hidden behind layers of icy crust. And there's even more. According to research, the water over in Europa is salty, much like the water we have on our planet. Europa is a big contender for the detection of life. But the Europa Clipper mission is not aimed at trying to identify this. Rather, it will orbit the moon and gather as much information about its atmospheric conditions as it can. The other moon-bound mission is the Dragonfly, an octocopter that will explore Saturn's moon Titan. The launch is programmed for 2027 and will only arrive in Titan's orbit around 2034. It will sample and examine a series of promising sites around Saturn's icy moon. And who knows, find some new information on ET life? Let's see what happens. But I'd say we've never been closer to a huge discovery than we are now. We're traveling through space at the speed of light. The route from Earth to the Sun at that speed will take only 8 minutes, but it would take us about 35 years to reach our destination, which is, by the way, still very fast. By comparison, a conventional rocket would take about 600,000 years to make the journey. And here we are. It's a star system suspiciously very similar to our own. And our scientists suspect that life could exist here, just like on Earth. A red dwarf, 30% the size and weight of the Sun, lies at the heart of this star system. But these are the planets orbiting the star that interest us most. The first of these is L9859b. Its size is somewhere between Earth and Mars, but it's very light. It's only half the mass of Venus. But life is impossible on this rocky planet. It's too close to the star, and it's so hot, you'd burn a cake if you tried baking it on its surface. It's about 100 degrees higher than the maximum of your oven. The planet makes a complete circle around its host star in just 2 days, compared to 365 for Earth. And it gets 22 times more energy than we get from the Sun. So it's not only hot there, but there's a lot of dangerous radiation. The next planet is 2.8 million miles from its host star. That's 13 times closer than the distance from Mercury to the Sun. And it makes a complete revolution around the star in 3.7 days. But what's interesting is that the planet is 30% bigger than the Earth and twice as heavy. So it belongs to the class of super-Earth planets. Such planets can be rich in water ice, methane, and hydrogen. These are some of the elements that are necessary for life's existence. Many scientists believe that it's on such planets that extraterrestrial civilizations can live. But because of the great weight of the planet, it has a strong gravitational force. So these civilizations may not be able to fly into space because it's harder for them to get out of the gravitational trap of a super-Earth planet. However, life isn't possible here because the planet is still too close to the host star. And just like in our solar system, the two nearest planets are too hot. But the third planet looks more promising. L9859d. It's almost twice as heavy as the Earth and 50% bigger. Scientists have calculated that about a third of its mass could be water. For comparison, the mass of all water on Earth is only 0.02%. The presence of water is the main condition for the emergence of life. But we can only guess where the water might be. It could be on the surface, but high temperatures can turn large oceans into giant clouds of steam. But water can also be contained in the groundwater below the surface. Well, we can't know that for sure yet. Let's move on to the next planet in the star system. This newly discovered planet is of the Super Venus class, L9859e. It's a rocky planet 3 times the size of Earth. The Super Venus class means that the planet is heavy enough to have an atmosphere, but the conditions there are more like a greenhouse. Different gases fill the atmosphere there. Star rays pass through them to the planet's surface, reflect off it, and rise upward. But the dense gases don't let them leave the atmosphere, so the planet gets hotter and hotter. This is the greenhouse effect that we try so hard to avoid on Earth. On top of that, the stellar wind carries water vapor and other elements from the upper layers of the atmosphere into outer space. Life cannot exist on such a planet, nor could it ever originate, just like on Earth's twin sister, Venus. So far, all the planets we've looked at are outside the habitable zone of the host star. That's the sweet spot at a perfect distance from the star. Not too close so that the planet isn't too hot and the water there doesn't evaporate instantly. And not too far away, so that the planet doesn't look like a cold desert. And planets B, C, D, and E are too close to the host star. But there's another hypothetical planet F in this star system, located right in this sweet spot. This super-Earth candidate is 2.5 times heavier than our home planet. So we have hopes that it's a rocky world, just like the other planets in this star system. The weight of planet F is enough to have a dense atmosphere, and the temperature on its surface should be suitable for water to exist there in liquid form. The planet makes a complete circle around its host star in 23 days, which literally means it's New Year every 3 weeks. It isn't very likely, though, that there's a civilization there that celebrates it. Indeed, the very existence of this planet is very doubtful, because we still have no direct evidence. All the other planets have been discovered by the transit method. That's when we point our telescopes directly at a star and watch its brightness change. When there's a slight drop in the star's brightness, that's when a planet has passed between us and the star. Like this dot. We have a short period of time while the planet is in the background of the star to determine its size and speed. Sometimes we can observe such transits of Mercury and Venus on the solar disk. And there are at least 29 potentially habitable planets out there in distant space that can observe Earth in the same way. About 1,715 stars within a few hundred light years are perfectly located for it. Each star has planets around it, but only 29 of them are in the habitable zone. So there really could be life and an intelligent extraterrestrial civilization out there. If so, they could point their telescopes toward the sun and see a small dot pass across the solar disk. And they could have been making these observations for at least the last 5,000 years. So they could see how our civilization was born and how we evolved. Moreover, these planets are close enough to pick up our radio signals and even television broadcasts. But it works both ways. Radio signals travel through space at the speed of light. We mastered this technology about 100 years ago. So if there really is a civilization out there somewhere, we would pick up their signals too. But so far, it hasn't happened. So we have no proof of the existence of life on these planets. The discovery of a star system like L9859 is very important to us because we're always looking for life outside of our solar system. And super Earth-class planets are even better suited for the origin of life than planet Earth itself. Such planets are sometimes called superhabitable. So some scientists think that Earth is a good place for life, but not the best. Superhabitable planets would have to be 30% larger than Earth and twice as heavy. This would create stronger gravity, which would make the atmosphere on the planet denser and with a higher concentration of oxygen. This in turn would raise the average temperature on the planet to a perfect 77 degrees Fahrenheit, so plants would thrive there. Also, stronger gravity makes the surface of the planet flatter, so there might be more oceans there than on Earth. This would make aquatic life much more diverse. The host star also plays a very important role. It should be smaller than the Sun. The bigger the star, the more of its fuel it burns. This means that the lifespan of such stars is much shorter. For example, the lifespan of the Sun is about 10 billion years, but a red dwarf can live up to 30 billion years. More time, more opportunity for the birth of life and evolution. So far, scientists have discovered 24 superabundant planets, but that still doesn't mean that there is life there for real. But some scientists believe that there are already at least 36 advanced civilizations in our galaxy, besides Earth. They've searched for similar worlds on the star map. First, we find stars that look like the Sun among about 100 billion stars throughout the galaxy. Now we choose from them those that are rich in iron. Such stars burn at the perfect temperature and help the planets around them gain an iron core and become Earth-like. Now let's pick relatively young stars from this pile, because when they get older, they expand and either absorb the planets around them or burn them up. One last thing, let's find planets in this pile that are in the habitable zone of the star. And voila! 36 worlds may be inhabited by some unknown civilization. But we won't know for sure until we get in touch with them.